Thank you, everyone. Can everyone, well, if you can't hear me, you wouldn't be able to be looking at me now. So thanks for coming. I'm Craig Lukasik, Specialist Solution Architect at Databricks. And if I'm too loud, just maybe raise your arm and I'll have them thumbs up. Too loud, too loud. I guess it's all right. All right, apologies if I blow your ears out. And so today we're here to talk about a new feature from Databricks Runtime 14.3 called the State Reader API. Obviously, you know. And this will hopefully help you with your development, troubleshooting of structured streaming, stateful structured streaming. Can you raise your hand if you have not worked with stateful structured streaming? Okay, okay, cool. So there we go. So I highly recommend like just reading the docs, but I'll make up a quick example of a stateful structured streaming scenario. So if you wanted to measure, say, or if you wanted to emit data that measured how many people are coming through the door, but say you wanted to every 5 minutes emit how many people have arrived in the last 1 hour, you might use stateful structure streaming because you have a little bit of counting to do before you emit that record. The docs have much more exciting details, but the challenge so far has been, and hold on, I got lost here. Oh yeah, so stateful operators include streaming aggregations, time window operations, streaming deduplication, and these arbitrary stateful operations. And in Spark 4.0, by the way, I don't have details here with it. There will be a newer API for these stateful arbitrary operations that gives a little bit more fine-grained control. But for now, we're just going to focus on Spark, I think it's 3.5 and DBR 14.3. And honestly, like, this is really the meat of the talk. I could pretty much leave right now and you could figure out the rest of it. But basically, there's two new data formats, Statestore and state metadata. So the syntax should look pretty familiar for anyone who's written, either PySpark or Scala. It's just another format. So you've probably seen Spark.read, format JSON or Delta, and this is just another thing. There is not a Spark.read stream, so right now we have to use the Spark.read, and we can talk a little bit about why that is. And so what makes this special and why I'm excited about it is that example I gave with the kind of the people walking through the door count is pretty simple, but like when things get complicated in a lot of use cases, and I've worked with various like telco or gaming use cases, that stateful logic is often complex. And as you're developing or debugging, sometimes you're wondering what the heck is in the state store. And I've used a gazillion print statements to figure that out. And the reason I'm excited about this API is it just lets you tap into that state store, that intermediate state data, and run with it. Oops. All right, so I have a quick demo. It's not really exciting. So let me just check my notes here. So in this demo, we're assuming that we have a data streaming into a Delta table that captures ad click events, and from a streaming media app. And before we show like the State Reader API, we'll add a couple stateful operations to it. So I'm going to just zoom through this part that shows like the fake data generation. So there's a blog out there and a demo that pretty much is everything I'm doing here that's out on Databricks.com. So this first part of the code is just setting up the stage for the fake data. So I'm kind of zoomed through it a little bit. Let's see, I'm gonna actually, let me see if this works. All right, that might blow up, in which case I'll run the other cells. Come on, cluster. I should have used maybe a different cluster. All right, so just go on. I'm going to show like the raw fake data before we proceed. So we'll wait a moment. Come on. And by the way, we will have questions in a little bit. And I'm told that I'm supposed to throw this at you if you want to ask a question. That seems like a disincentive for asking questions, but I'm happy to hand it to you if you don't want something, whipped at you. So. All right. So, and let me just bring my notes over here. Okay, good. All right, so this is the raw data. So think of like a media app where for some user profile, they're shown an ad, and we just are collecting whether the ad was clicked or not. Right, so that's kind of the raw data. So now what we want to do is introduce some stateful operations. So so not used to using my trackpad. All right, so the first thing we're going to do here, and again, this is not the state reader API yet. This is just setting the stage with the fake data. So we're going to add an operator that'll drop duplicates within a 1 minute watermark. So think of this as one stateful operation. And if you think about it, if you get that event, and this happens pretty frequently in real world use cases, you might get duplicate events. You need to get the data out the door. So you're usually saying, well, we want to just bound this to some watermark and then drop duplicates and then emit that record. Now what we're going to do beyond this though is now we're going to take this drop dupes data frame and create a new one off of it that's going to introduce another aggregate stateful operator. So this one is kind of similar to the scenario I explained before, but in this case what we're doing is we want to aggregate those click counts by count the profile IDs that have clicked on the ad within a 5-minute window, and basically aggregate it grouping by the advertiser ID. So you can kind of see how that data frame structure has evolved a little bit, and now the fun stuff starts to happen. So this next cell is just saying, let's write this to Delta Lake. Now you'll notice this checkpoint location, and there's a lot of stuff happening underneath the hood for checkpointing. Is anybody unfamiliar with checkpointing? All right, we got a good crew here. I like y'all. All right, so as you know, as that microbatch, is completing, it's going to be checkpointing data, persistent storage. I didn't show it. Well, I'll go to the top here. So we typically recommend this RocksDB Statestore provider as your Statestore class, and that should scale to a lot of keys. Hundreds of millions of keys we see in some use cases. And let me just find where I was before. And I'll check my notes as well. All right, perfect. All right, so that's it. I'm not even going to run this because I ran it before, but this should work for us. And I'll just, I'm not even going to run it because I don't want to chance it. But this starts to introduce us to this new API. So there's two APIs. This first one is the state metadata format. And so this helps us understand the high level details for each operator. And we can see we have two operators. So that Statestore save is kind of, I think, the generic windowed aggregation operator. And then this one is a little bit more intuitively named. We saw that we're doing that drop duplicates, I think, within a 1 minute window. So we get a sense of as you have those operators, you can kind of see what's happening in terms of that state store. So this is great. The state store name, you're seeing default here. If you have like multiple stateful operators chained together, or like a stream to stream join where each stream has its own set of windows and stuff like that, you would see something. I don't know what it's named after, like default is used, so I haven't played with it to that extent yet. But you can also start to see things that will be helpful if you start to see like performance issues or skew issues. So so we can see that there are 200 partitions. So that is the default for the shuffle partition. And so if you think about if you have a large set of keys or large state values, that default of 200 might not be great. So this is where this API starts to be useful, just because, and oftentimes you don't even think about what is that spark.sql.shuffle partitions value, but this is where it can start to just pop out and let you know that something's wrong. And then you can also see that there's a min batch ID and a max batch ID. So that is because as those micro batches are kind of churning along and kind of pulsing, it's going to be persisting, the historical checkpoint data. So you can kind of go back in time a little bit. I think there are 100, and I might have the default wrong, but in like the object store, there will be like 100 historical batches that if you wanted to kind of go back and look at what happened here and then next, you could do that. All right, so now let's see. I think that's all I've got for that one. Now we'll jump down to this other API. Again, it's pretty simple. Read format state store, and this I think is like the most beautiful part of this, because like what you're storing in state. So especially like if you think about arbitrary stateful operations, you can have a schema for the key, a schema for the value. And then again, like before this API was there, like you just had to hope that you were getting it right in terms of what you're actually stowing away. So you can imagine how this could help. And honestly, like that's the meat of this like whole presentation. So I'm just going to jump back and kind of recap a couple of things if I can navigate this. So the state reader API, hopefully will minimize the pain and sort of those kind of I used to like just use a single node cluster and print messages to figure out what the heck was going on in my state store. So hopefully this will make it easier to like develop and iterate a little bit faster, and you can get rid of those gnarly debug print statements. Also, it opens up the opportunity to have better unit testing kind of built into your stateful workloads. And and let's see what else we got here. And then similarly with production issues, so we have use cases sometimes where, a ticket, is raised because a client called in, or some analyst is saying, "Hey, I expected this. What's going on?" So again, in the past, it was like, well, who knows? It's something might be in the state store that isn't yet emitted. So now, hopefully, that should be much more enjoyable experience. Although production issues are never quite enjoyable. And so to recap, use a high-level state metadata format to get just a big picture view of what's going on. And that's kind of legible, I think. And use a state store format to dive deep into the fine-grained key and value details. I'm not using an option here, but you can specify the operator ID. Let me just jump back here. So this is one option. So if you have multiple operators, you'll need this option to kind of instruct at what state you're interested in. yeah, so when do you use this thing? Development. Hopefully it's going to speed up and make it just less painful, that development and test cycle. That question of skew, and actually, hold on, I just realized I forgot a bunch of things. Yeah, so the nice thing about this Spark.read format, you'll get a data frame back, and then you can do all the normal stuff you would do with the data frame. Register a temp table, and in this case, I've got a little query then that is just looking for skew. Like, since you've got this state store and it's organized by your keys, are you like finding more keys going to one partition, and that could introduce, tell you that there's some skew you need to worry about. And in this case, yeah, we don't see a ton of skew, and so that's not too bad. Whoop. So that is it in a nutshell.